Hello everyone, welcome to MSys Podcast series. This is your host Apeksha and joining us for today's show is Vaibhav Jain. Hi Vaibhav.
Hi Apeksha, how are you doing?
I'm doing well Vaibhav, what about you?
I'm good too.
Thanks for being here with us today. So Vaibhav, can we start with your introduction?
Yeah, so I pursued my master's from Ramdev Baba College of Engineering and Management, Nagpur. I have worked in big data analytics domain, specifically in TV media domain. My area of expertise is Java, specifically Java 8, and I have been involved in learning Scala since over a year. My area of interest includes data extraction, data analytics, and functional programming. Here at MSys, I am currently working as a software developer in virtualization domain. We are developing a VMware plugin for fast VM snapshot provisioning by using native enterprise storage system.
Okay, that's great to know. So Vaibhav, why Scala? Why Scala is such a popular language?
Yeah, so Scala is an acronym for scalable language. That means Scala grows with you. At the root, Scala scalability is the result of careful integration of object-oriented and functional language. What makes Scala scalable is its combination of object-oriented and functional programming. Where other languages might have objects and functions as two different concepts, in Scala a function value is an object. Scala runs on the JVM. Another advantage of Scala is its integration with Java. So Java and Scala classes can be freely mixed, irrespective of whether they reside in different projects or in same. Java has a very rich class library and we can use all these Java libraries, frameworks and tools in Scala. There are some of the largest companies in the world that are using Scala like LinkedIn, Twitter, Coursera, Zabbia, Xerox, Foursquare, Sony, Siemens, to name just a few.
Okay, great. So having said that, there would be some pros and cons to Scala programming, right? Especially for the
Yes.
agile software development.
Yeah.
Would you mind explaining what makes Scala great and what are the possible drawbacks?
Yeah, sure. So there are four of the most important aspects of Scala: compatibility, brevity or conciseness, high level abstractions, and advanced static typing. So let's first talk about compatibility. Scala programs compile to JVM bytecodes and their runtime performance is usually on par with Java programs. Scala code can call Java methods, it can access Java fields and inherit from Java classes, and also it can implement Java interface. None of these requires special syntax, explicit interface descriptions, or glue code. In fact, almost all Scala code makes heavy use of Java libraries, often without programmers being aware of this fact. Another aspect of full interoperability is that Scala heavily reuses Java types. It not only reuses Java types, but also dresses them up to make them nicer. Scala code can also be invoked from Java code. Now let's talk about conciseness. Scala programs tend to be short. Scala programmers have reported reductions in number of lines up to a factor of 10 compared to Java. These might be extreme cases, but a typical Scala program should have about half the number of lines of the same program written in Java. Fewer lines of code means not only less typing, but also less effort at reading and understanding programs and fewer possibilities of defects, which avoids some of the boilerplate that burdens Java program. Scala's type inference is another factor. One of the most important aspects of Scala is its high level. It helps you manage complexity by letting you raise the level of abstraction in the interfaces you design and use. The Java code treats strings as level entities that are stepped through character by character in a loop, while Scala code treats the same strings as higher level sequences of characters that can be queried with predicates. So clearly the Scala code is much shorter and is easier to understand than the Java code. Another aspect of Scala is it is statically typed. Scala stands out as a language with a very advanced static type system. It gives a strong foundation for building and composing your own types so that you can design interfaces that are at the same time safe and flexible to use. Verbosity is avoided through type inference and flexibility is gained through pattern matching. Scala brings us the match statement that looks like a switch statement, except that it can select on just about anything. These were some of the important aspects of Scala. Now let's talk about its drawbacks. It can take a significant amount of time to learn all these concepts of Scala. Some people say that Scala syntax is more complicated than Java, but in fact the language spec for Scala is significantly as small as 191 pages, whereas the language spec for Java is 684 pages. Here you see the difference. Another drawback is there are far fewer developers who already know Scala than who already know Java, which I would say is indeed an opportunity. The development tools for Scala are not as advanced as for Java, but they are evolving. Also, since the language is new, there are limited online communities and resources to help you troubleshoot your issues.
Okay, that sounds interesting. Can you also cite some examples of Scala use cases?
Yeah, the biggest development in Scala has been Apache Spark, which is the big data processing framework. As somewhat of a successor to Apache Hadoop, Spark is seeing enormous growth in adoption and interest, and the fact that it is written in Scala is drawing many to the language. Spark is complemented by a host of companion components which are also written in Scala like Kafka, Spray, Samza, and Scaling. Kafka is an open source message broker which can easily scale to handle millions of messages per second. Samza is a distributed system processing framework which is underpinned by Kafka.
Okay, Vaibhav. We would also want to know what is the difference between using Scala and Java for big data engineering.
Yeah, Hadoop is mostly written in Java and Spark is mostly written in Scala. It can't be argued that Scala is the easiest and cleanest language to implement Spark programs. You see, even though Java 8 and Spring Boot are working on reducing boilerplate code, most of the Java you face is not going to be ultra clean. It remains somewhat verbose. You can definitely write nearly anything in Java, but the lines of code required to write can be daunting. On the other hand, programming in Scala has a slightly more complex structure, but you can write a slightly more complex single line of code that replaces 20 simpler lines of Java. Scala has features that enable the programmer to write compact code as opposed to verbose code, which is in Java. As I said, less code means fewer bugs and less time spent on maintenance. You see, TypeSafe, which is now Lightbend, is doing fast data analytics in Scala. Akka is very powerful and written in Scala. Looking at the number of projects, number of developers, and the number of companies, you can see as of now, in the numbers game, Java is way ahead of Scala. Scala is ahead in clean code and concise code. But in my opinion, both languages and especially the JVM will be part of big data for years to come.
Alright, so why is functional programming and hence Scala, of course, important for big data?
Well, as for big data, the term implies a set of problems that are too large to handle with conventional approaches, and this generally involves a certain amount of parallelism. However, parallel processing is plagued by changes in state. If two parallel processes are attempting to change the same data, the result might be delayed or unpredictable. By reducing or eliminating mutability, functional approaches tend to lead to programs that naturally and simply handle concurrency and scalability. You know, Scala is the only language which is statically typed, multi-paradigm, and runs on the JVM. What makes Scala important for big data is its strongly static type, expressiveness that leads to concise code, simpler and safer concurrency programming model, running on JVM, playing well with existing Java applications.
Okay, great. Also, if you could throw some light on how can we choose the right programming language for big data initiatives?
That's a good question. Well, many factors have to be considered. From what types of legacy systems you have at your disposal to the talent and skills within your organization. The leading champs nowadays are R language, Python, Scala, SAS, the Hadoop languages, and of course Java. Almost half of all big data operations are driven by code programmed in R language. Well, R is powerful for big data analytics, but it isn't as strong as general purpose language. For example, you can put together a good model using R, but you would probably end up translating it into Python or Scala before putting it into production. Python is relatively easy to learn as it's just another object oriented language for developers to master, and also it has distinct advantage of being easy to read by humans. Now let's move to Scala. It's an admirable pairing of functional and object oriented languages and is tremendously popular in financial industry where companies need to be able to work with massive sets of widely distributed data. Kafka and Spark are both powered by Scala and you can do lots more with far less code in Scala than in Java. Scala is also a full-blown functional language. Many traditional design patterns in other languages are already natively supported in Scala. For instance, singletons are supported through object definitions and visitors are supported through pattern matching. The last one is Java. The biggest problem with Java is that it's ridiculously verbose and there is no REPL, that is read, eval and print loop, for iterative development as there is with others on this list. However, Java 8 has come a long way in terms of verbosity and is much better.
Okay, so are you saying that Scala is the next big thing in the big data world?
Yes, it is. You see, Hadoop is written in Java and surprisingly has reached a decade in age. In that time, the volume, velocity, sources, and types of data have grown exponentially. From the smartphone to the refrigerator, everything nowadays is generating data. Java is quietly and slowly passing the big data processing baton to Scala to incorporate real time data handling. Spark can run programs up to 100 times faster than Hadoop MapReduce in memory. It also provides a 10 times speed increase in using disk processing. If we look at the companies participating and investing in big data using Scala, we see some of the biggest names in digital economy. Kafka was created by LinkedIn. Scalding was created by Twitter. So it is obvious why Scala is the natural language for the next generation of big data handling. Scala is object oriented, functional and statically typed. It has powerful combinators, mapping, pattern matching, monoids, currying. These are all crucial capabilities which align quite naturally with the processing functionality required for analyzing big data.
Okay, so according to you, then Scala will bring in a revolution in the big data world, is that?
Yes, I do think so. Gradually, but definitely. One of the most popular uses of Scala is building big data pipelines in Apache Spark. While Python and R have proven popular among data scientists, Scala has been heavily adopted by Web 2.0 and social media companies such as Foursquare and Twitter, which in 2009 migrated from Ruby to Scala for most of its backend systems. Spark gave the developer a choice of languages for developing apps. Spark was actually written in Scala and supports Scala, Java, Python, and R. In my opinion, Scala has this potential of conquering the big data world.
Brilliant. So that ends our discussion for today. Vaibhav, it is great to hear about Scala and now how it has become an integral part of big data analytics. Thank you, Vaibhav, so much, and we hope to see you again.
Thank you, Apeksha. It was pleasure talking to you.
Thank you so much. Thanks for listening, folks. For any feedback that you have about our podcast, you may write to us at marketing@msystechnologies.com. Till then, bye bye and take care.